Welcome to our CS231n Deep Learning for Computer Vision project. We present to you Deep Learning for Pediatric Cardiology Imaging. The team members are Sarah Shuhaibar and I'm John Ngoi, the presenter. After a pediatric ultrasound, a clinician uses perpendicular videos of the left ventricle to assess cardiac health. These views must be identified among many files produced during the echocardiogram, which is time-consuming. We built a convolutional neural network to identify these videos. Achieving good accuracy proved to be challenging. During a cardiac ultrasound, a clinician captures several short video clips and still images of the heart from different viewpoints. The left ventricle, which is the main pumping chamber, has the broadest implication for cardiac health in pediatric patients. Clinicians need to be able to isolate views of the left ventricle for evaluation, which requires identifying 1 to 2 specific video clips among the full set of video clips and images from the echocardiogram. These images can be identified by a trained echocardiographer, but this process can take a substantial amount of time. In this project, we trained a deep learning model to identify the target videos from full echocardiograms. A full cardiogram consists of around 100 still images and short video clips. From the full echo, we want to isolate 2 video clips that show perpendicular views of the left ventricle, which clinicians can then use to assess the left ventricular function. Because both left ventricle videos are needed to assess cardiac health, we do not distinguish between the two and simply classify a video as being one of interest or not. The dataset for this platform is Pediatric echocardiogram provided by Dr. Charita Reddy at Stanford Children's Hospital. The dataset has 2 components. 122 pediatric echocardiogram, which consists of approximately 100 still images and short video clips each, for a total of 12,197 files. These echocardiograms are unlabeled. Given challenges processing these medical files from the original format, only the video files were used in our classification model, and the still images were discarded. Second, we have another 4,370 video clips of the left ventricular, and these consist of the 2 views we are interested in. These video clips are the target videos that we want to identify from the full echocardiograms. We built a neural network inspired by Madani et al.'s echocardiogram classification architecture. We trained this network on an unbalanced dataset of target and non-target images and then froze everything besides the final layer to train on the balanced dataset. Our trained network only reached 42% accuracy on the test set and focused less and less on hard features as training continued. In conclusion, we did not achieve the hoped-for accuracy in identifying left ventricular videos from full echocardiograms, possibly due to either the unbalanced classes or additional image artifacts around the borders. We will recommend anyone else approaching this problem to consider an unsupervised classification approach with a larger number of classes, potentially narrowing down the number of videos an echocardiographer would need to view to identify left ventricular videos. Although transfer learning is common in image classification tasks, using models that are pre-trained on popular image databases such as ImageNet may not offer performance gains in this domain over training model from scratch due to differences between ImageNet and medical images. We recommend that future work explore transfer learning using a model trained on medical images. Because we approach these tasks as an image classification problem, our approach does not make use of spatio-temporal information in the videos. There is likely information in the optical flow that can be used to classify using an approach such as. We would like to thank Dr. Charita Reddy for taking the time to walk us through this domain and problem, providing us the datasets and giving us guidance throughout. We would also like to thank Timothy Chu for having us in this moonshot project to improve the lives of pediatric patrons. Thank you for your time, and I hope you enjoyed this presentation.